Instances. While we wrote the restaurant program simply to introduce you to classes, the object classes you created have much more use. When you created the class server, what you created is the ability to have as many server objects as you would like or need. These are called instances of a class. Every time you declare and initialize a new variable of type server, you create an instance of the server class with its own attributes and behaviors. Since a restaurant would have many servers, it is easy to see the need for several instances of the server class. Class attributes belong to the class. Regardless of the number of instances created, a class attribute holds the same value for all of them. Instance attributes belong to an instance of the class. They are unique to each object created and can hold different values. For example, let's declare two attributes, both named numTables, in our server class to store the number of tables servers will have at any one time. One attribute will be declared inside the class but outside of any methods. The second attribute will be declared in the init method. You will see how a class attribute differs from an instance attribute. Note, you might see the words variable and attribute used interchangeably. Much like how a method is a function that deals with classes or objects, an attribute is a variable owned by a class or object. Below, numTables has been declared outside of any method. It is a class attribute. So inside the server class, but outside of any other methods, we have numTables equals 5. The next thing we're going to do is create an instance of the server class like this. So outside of the server class, we're going to have Pierre equals server. So we're creating an instance of the server class. Currently, numTables is a class attribute since it's declared inside the class but outside of any other methods. We can access numTables through the class name like this, server.numTables, or through one of our server objects, like for example Pierre.numTables. It is considered good practice to access class attributes through the class name, like this, server.numTables. If we create another attribute called numTables, but declare it in the init method, let's see what happens. So here, this is going to actually create an instance attribute that belongs to every instance of the class that is created. So here we have Pierre is a server, print Pierre.numTables. Pierre.numTables now accesses this attribute, which has a value of 3. However, the class attribute still has a value of 5. So by declaring this instance attribute, we have not changed the class attribute. You have to be careful with class attributes. If you modify a class attribute by calling it from an object, it becomes an instance attribute. For example, here we no longer have numTables in the init method. We just have numTables as a class attribute. We create two server objects, Emily and Pierre. Then we say Pierre.numTables equals 3. What this does is create a new instance attribute called numTables and set it equal to 3. So this did not change this 5. This just created a new instance attribute. So if we then print Emily.numTables, that's still going to access the class attribute, whereas Pierre.numTables is now going to access the instance attribute. So when you print them out, you see we get 5 and 3. In our restaurant program, we do want each of our servers to have a different number of tables. So let's implement that. Let's only define numTables as an instance attribute in the init method. This way we can pass in a value for the number of tables a particular server has when we create the server object. So we no longer have a class attribute called numTables, we only have instance attribute, and we can pass an argument to the init method when we create those server objects.